Hey everybody, this is another video for the separation of a mixture pre-lab assignments. Again, hopefully you're doing well, and sorry that we can't be together, whether it's you or me, that's not there. So I just want to share my screen with you. We're going to go through our decision matrix assignment. So I'm going to jump over here. Again, it's going to be separation of a mixture matrix. You're going to find that, click it, open the document that's attached. I believe you have to load it. Let me look at it. If you open this, actually, you don't need to make a copy. Once you hit this load in a separate window thing, that is going to make you your own copy every time. It's only when you're clicking a link and it opens that you'll have to do that file, make a copy. So I misspoke in the previous video. I apologize. But once you're in there, you're going to find, not that one, we're going to find this one. Okay. So separation of a mixture matrix. This is our decision matrix. We're going back to that engineering process that we talked about in the early weeks of our semester. You'll be engineering a process to separate a mixture of salt, sand, and iron. Then you will use your process and evaluate it by calculating your percent yield of each component of the mixture. The problem: your group is charged with developing a process to separate a mixture of salt, sand, and iron. And here are your criteria and constraints. Each component to the mixture, salt, sand, iron, needs to be separated as cleanly as possible, purifying each component as best as possible. You must be able to measure the mass of each component after the separation is done. You are limited to an hour of class time to complete the separation in our block day, plus 10 minutes of class time in the next class period. And if I'm ever doing this lab and it's not actually a block day, you'll get the whole class period on one day and then 10 or 15 minutes in the next day. If you are limited to the materials in our classroom, including all glassware, funnels, filter paper, magnets, water, transferring tools, evaporating dishes, and others with consent from the teacher. So don't put one of those in your idea, another piece of equipment, without first getting clearance from your teacher, okay? All right, decision matrix. In the matrix below, fill in the criteria and constraints. You may paraphrase them so that they fit nicely. I'm going to do this with you. Then add the ideas. You must have at least 2. The ideas do not need to be detailed in this matrix. You will develop details later, but you must describe them enough to give an impression of what will be done, okay? I'll give you more information on what I mean by that in a minute. After filling in the criteria and constraints, as well as the ideas, choose a scoring method from your engineering notes and score the ideas to determine which one to move forward with. Okay, so you do need to score out your ideas afterwards. As a group, you guys can work in the ideas and scoring. Remember those scoring methods. There was 1, 0, -1. There was rating and there was ranking. All of those were discussed in detail in those engineering notes. Okay, that's at the front of your notes packet if you forget. Okay, so criteria and constraints. Let's just look at this. I have 5 boxes here. Up here, there are 4 bullets, so let's just fill in these. Each component needs to be separated cleanly as possible. So clean separation, clean separation. Clean separation, we'll put there. Sorry about that. All right, the second bullet, you must be able to measure the mass after the separation. So mass capable, I'm just gonna put mass capable. It means I have to be able to measure the mass of each substance or each thing, each chemical afterwards, okay? The third bullet, you are limited to an hour of class time plus 10 minutes of class time in the next class period, okay? So 70-minute limit. The fourth one, the materials, okay? So classroom materials. Class materials. And then if you want to come up with another one, You can add one here. If you want to add more than one, you can certainly divide. Well, one thing you could do is if you highlight a column and you right click it, you can insert a column to the left or to the right. It'll add another column to the table and you can add in there. You can do that if you want to. You do not have to add another idea here, another criteria constraint, or you can add more. It's up to you. All right, over here again, ideas. I'm going to give you the first one. Here's the first one. I'm just going to paraphrase super brief. Tweezers, okay? You just take a pair of tweezers and you grab a grain of salt and you put it in this pile, and you grab a grain of sand and you put it in this pile, and then you grab a iron filing and put it in that pile, okay? You can do that with your whole sample. You can use tweezers to take your sample apart grain by grain. They're all solids and they have different colors, so you could do that, okay? That's one idea. The next idea is up to you and your group. If you want to come up with more than one, these might be similar to each other, but with some steps reversed. And so here's what I will say with that. If you are coming up with a process, I don't want you to spell out the whole procedure of your process right here, but you might like briefly state the steps. For example, if I'm baking banana bread, my steps might be gather, mix, bake. Right? Gather all the ingredients, mix them in the right amounts, and obviously I would have a recipe to follow with that, and bake at a certain temperature and a certain time. The details of making banana bread are much more detailed than that, right? But I can simplify the steps into gather, mix, bake. So if you have a series of steps that you're going to be doing to separate these three things in your, this is your second idea, maybe just really briefly list what the order of the steps would be, all in one box. Okay, so I would write, if this was a banana bread, I would write gather, mix, bake. That's one idea for making banana bread. But we're not making banana bread, so you do this for the separation of a mixture lab. Then you need to score out both of your ideas, come up with a total score. Okay, if you have 3 ideas, score out all 3 and then come up with a total score. When you finish that, you've got a total score, you've got a winner. You need to have a winner. If you don't have a winner, try a different scoring method and see if you can get a winner. You're going to take that winning idea and you're going to go to the next assignment in Canvas and you are going to make technical drawings for your winner, okay? And what a technical drawing is, it explains it on the assignment page, but you need to illustrate with pictures the process that you're going to use to separate. But not only are you illustrating with pictures, don't forget the pictures. It's a drawing, okay? Illustrate with pictures, but you also have to add words to explain what's happening, what materials you're using, what are some of the time constraints or estimations of time for each part of the process, okay? Don't forget at the end of your process, whatever your process is, your last step should be weigh the salt, weigh the sand, weigh the iron. You need to show that you're getting their masses at the end. That has to be a part of your picture. Hopefully that helps, and good luck with this assignment, and I will see you in class for the lab.